Sir, can you upload today's class recordings?
Yeah, I will. I will do it tomorrow morning, huh?
Yes, sir.
Because night time the data is very slow. Morning it is very fast. I can upload faster. Okay. So we are going to have discussion on induced EMF first. Huh? What is called induced EMF? Please write the heading induced EMF. Did you write? Hello, Abir. Abir. Okay. Now you see. First understand, then you write. Huh? Look, we have a magnet here, right? And
Yes, sir.
the magnet is showing you the magnetic field lines, north to south.
Yes, sir.
Okay. And the motion of the conductor, you see, direction of motion of wire. Someone is holding the wire. This wire, someone is holding and moving upwards through the
Yes.
magnetic fields. Then what will happen? Uh, the observer will see that this needle is moving.
Yes, sir.
This instrument is one emitter. Okay, so this emitter shows deflection. That means there is current.
Yes.
Though there was no current before, but now because of the motion through the magnetic field of the conductor, there is current, right? Isn't it? There was no current before. It's only if it is not moving, the conductor is not moving, just you are holding it, then you will see the needle is showing 0. Is it clear? Hello? Abir? Hello, Abir? Hello? Abir?
Yes, sir. I got disconnected again.
Yeah, I can see you got disconnected. So, if someone is holding this wire and not moving, then you see the needle will be in 0. Huh?
Yes, sir.
But if this needle is, if the wire is moved upwards, then the observer sees that the needle moves or deflects, right? It gives some reading.
Yes.
So from here we understand that if the field lines, magnetic field lines are cut by any wire, then there is induced EMF and because of this induced EMF produced, we have induced current.
Yes, sir.
And this uh, process is called electromagnetic induction.
Hmm.
This process is called electromagnetic induction. Okay,
Yes.
is it clear? So
Yes, sir.
that's why it is written here electromagnetic induction in a wire. And
Hmm.
this process, uh, you see, is following Fleming's right hand rule. Fleming's right hand rule. Look, here the thumb is upwards
Yes, sir.
and the magnetic field is left side. If you are using your right hand, then you'll understand thumb is upwards and magnetic field is left side, then your current direction is towards you, right?
Yes, sir.
Isn't it? You see the current direction here, we are getting here towards you, right? Out of the
Yes.
page
Hmm.
or out of the screen. So it is the direction of induced EMF or induced current
Hmm.
using the Fleming's right hand rule. Okay. So
Yes, sir.
in this rule we are having electricity from the motion. Okay.
Hmm.
Is it clear? So you
Yes,
draw
sir.
this diagram now. Please draw this diagram now. Then label everything and also write electromagnetic induction in a wire.
Hmm.
For after drawing and labeling everything, writing the caption, you write
Hmm.
this for electromagnetic induction we use Fleming's right hand rule
Hmm.
to get current direction. Okay, induced, you write here induced current or EMF direction. Here we get electrical energy from motion or kinetic energy or mechanical energy. Are you writing?
Yes, sir.
Drawing is done.
Yes.
Okay.
Yes, sir.
So these are the core ideas.
Hmm.
You should memorize them. You should remember them. If you can
Okay, sir.
remember this, you can get, you know, everything here. All the questions you can answer from electromagnetic induction. And there is another point. We can uh, get greater amount of induced EMF or current if we have greater motion of the coil where
Yes, sir.
or stronger magnet
Hmm.
magnet or more number of turns of the conductor
Yes, sir.
if you have more number of turns, that means you are having magnetic field lines cut more, right?
Hmm.
If the magnetic field lines are cut more, then there will be more induced EMF, isn't it?
Yes, sir.
So three things. If the motion or speed is more, uh, greater motion, I said here greater motion, that means greater speed, right? You can write
Yes, sir.
oblique slash speed, speed of the wire, or stronger magnet, or more number turns of the conductor. Is it clear?
Yes, sir.
Conductor means wire, the copper
Hmm.
wire we are using. So we are done with many ideas, right?
Yes.
Alhamdulillah. In this diagram, we had lots of ideas here. Look, we have some more things. Ah, um, here we go. So we can bring the book here again.
Oh, sir, I did not finish writing.
You did not finish writing?
No, sir, I was in the last para.
Oh, I see. Uh, now, now you can see. Can you see, Abir? Hello, Abir. Hello, Abir. Hello, Abir.
Yes, yes.
Okay, can you finish them now?
Yes, sir, 1 minute.
Uh, if possible, please manage backup data. Huh?
Hmm.
That will be better. Mobile backup data during class. Otherwise, our class is hampered. Huh? Again and again.
Yes, sir. Yes, sir, done writing.
Okay. You have this book, right?
Yes, sir.
Now you will write write Faraday's
Hmm.
law of induction. This heading you write Faraday's law of induction.
Yes, sir, I wrote.
And then draw this diagram. Huh?
Hmm.
Here we are having one magnet and there is coil. Huh?
Yes, sir.
Coil of wire that is called solenoid and one
Hmm.
galvanometer. Galvanometer is a device which is detecting the presence of electricity.
Hmm.
Okay, so is only detecting the presence, not measuring the amount, how much or how many amperes
Hmm.
are there. Is it clear? So this is
Yes, sir.
galvanometer. And here we are getting opposite of the previous diagram you did. Uh, like that one, you are moving the wires, right?
Yes,
In
sir.
that diagram, you are moving the wire and the magnet was fixed. Now we are having the magnet is moving towards the coil is fixed. And because of this, we are getting induced EMF. Is it clear?
Yes, sir.
So we can get induced EMF by moving the magnet or moving the conductor in both ways.
Hmm.
Uh, but the same thing is happening here and there, that is magnetic field lines are cut by the wires. Magnetic field
Yes, sir.
lines are cut by the coil. Magnetic field
Hmm.
lines are cut by the conductor. The same thing is
Yes, sir.
happening, right?
Yes.
So you, after drawing, you write this information here, what I am writing. we can get induced EMF current also by moving by motion of a magnet towards or away from the coil. Okay. Are you done with writing?
Yes, sir.
Okay, then write the law of Faraday's law of induction statement.
Hmm.
This one you write. Statement. You write statement, then this one you write. Can you read it, please?
The first blue box.
Yeah.
The EMF, electromotive force generated in a conductor, is proportional to the rate of change of magnetic, thus linking the circuit.
Yeah, write it. What is magnetic flux? Beside flux, you write what I'm writing here. Beside flux, give a slash. Give a slash, then you write
Hmm.
magnetic field lines density. So is it clear?
Yes, sir.
That means rate of change of magnetic flux means magnetic field lines density. So the magnetic field lines cut by the wire, if the number of field lines are cut more, then we will have more EMF. Is it clear? Hello? We got before that, right? Hello, Abir? Abir? Hello, Abir? Yeah. So we got before this one. Magnetic field lines are cut by the
Hmm.
coil or conductor that is producing
Hmm.
induced EMF, right?
Yes, sir.
Now it's said in different way. They are saying is proportional to the rate of change of magnetic flux. Flux means magnetic field lines density. You, after writing flux, you give a
Yes,
slash,
sir.
then write magnetic field lines density. Okay?
Yes, sir.
And look Are you done with writing this statement?
Yes, sir. Yes.
Okay, you also wrote this, magnetic field lines density beside flux.
Yes.
Okay, very good. Now look here. What we said, those 3 points are given here also. The magnitude of the induced EMF depends on the number of turns of the solenoid, the strength of the magnet,
Hmm.
the speed with the magnet is plunged into or withdrawn from the solenoid. So we got before that, right?
Yes, sir.
And there we got the wire is moved up. That's why the emitter is moving right side. If the wire is moved down, then we will see the emitter will move or deflect left side. Is it clear?
Yes, sir.
Hello. So if this magnet is taken towards the solenoid, you will get the deflection one side, and if the magnet is taken away from the solenoid, then you will get deflection in opposite side. Is it clear to you?
Hmm. Yes,
Hmm?
sir.
So we got here how many learning outcomes. Now we check here,
Hmm.
in the learning outcomes of the topic. We are going to discuss them. Look here, we had this first one, describe an
Yes, sir.
experiment which shows that a changing magnetic field can induce an EMF in a circuit. So changing magnetic field means magnetic field lines are cut, right?
Yes.
Then state the factors affecting the magnitude of the induced EMF. We also did that, right? So these two learning outcomes are done.
Yes, sir.
We are done by these two learning outcomes. Now we are going to do learning outcome C, that is Lenge's law. You see here spelling Lenge's law.
Yes.
You
Hmm.
write this heading Lenge's law. Okay.
Yes, sir. Yes, sir. I wrote.
Lenge's law starts from here. This is the law, but we are not writing the law now. First we understand it, then we will write the law. Okay.
Sir, I cannot hear you properly.
Yeah. What I said, Lenge's law start from here. Now you can hear me.
Yes. Yes,
Lenge's
yes.
law
Now it's
start
fine.
from here, but we are not writing the law first. We will understand the process first, what he did, eh, what is his experiment and understanding. That one we will try to get it first. Is it clear? Then we will write the statement like the Faraday's law. Is it clear? Eh?
Yes,
Okay.
sir.
So we got here uh, Lenge's law, the first diagram you see 23.4. This one we'll discuss, but before discussing this one, we will go back to right hand grip rule. Can you remember right hand grip rule? There was straight wire, and we had magnetic field lines around the wire. Can you remember that one? We did in last topic. Hello? Hello? Abir? Hello, Abir? Abir? Abir?